Okay, so here's my module 2. First, talk about the engineering design process for this. Our ask, or our question we need to answer, was what was the best land cover for a healthy watershed. So imagine possible solution was to design water tanks or water areas to test the water runoff for different types of land cover. So my plan was to pretty much follow the plan from the example, using water bottles as the tanks and the different soil types and the pouring water on them to simulate rainfall and seeing what the runoff water looks like when it flowed out of the bottle. Then we collect and compare the water. When I created it, made the water bottles, made sure I collected my soil samples. And then to improve it, I'd probably say use a larger test area, so something bigger than a 2-liter bottle. Maybe use like a 55-gallon drum or something, or even use a field, kind of like what Penn State does with their grass testing. And then integrate different kinds of land cover, so more than what I did. So here are my surfaces that I did. I actually found a piece of my road got hacked off of the road, so I decided, alright, well, I'll use that and see what water runoff does with that. Then some loose soil here, doesn't have any roots in it, and then some dirt with some roots and some grass in it. So you can see here I'm going through it, pouring water onto it. So there I'm pouring it on the road, on the loose soil, on the grass. So results, this is what the water looked like that poured off of the road. This is going to simulate really high rates of water runoff, so kind of going into that suburban setting. We'll have a lot of concrete or a lot of roads or a lot of industry that's developed. You're going to see a lot of water that gets run off, and it could carry anything that's on top of there into the watershed. Loose soil, you can kind of see here. Anything that was loose kind of got washed off into the drain, or washed off as well. So a lot of soil and dirt from the top got let loose. And then the third one, where it had grass and roots, it wasn't quite so clear. I think I probably could have set this design up a little bit better. But it was definitely not as dirty as the water that I had from the loose soil. So it did retain some more water. And I will say it took a lot longer for this water to actually leak out of here. So here's a side-by-side comparison. This is the road right here. That's the loose soil. And then that's the grass runoff area. Again, a closer look here. Again, that's the road, that's the loose soil, that's the grassland, or the grass. So, as far as standards and how we would align to it, I'm in high school, so I looked for a 9th grade environmental literacy and sustainability standard from the PA Steel, since we're coming out with that soon. So, the one it most aligned to was 3.4. Here's the foundation box over here that's linked to the standard. But you want to analyze and interpret how issues, trends, technologies, and policies impact watershed and water resources. So different kinds of surfaces that people allow in their watershed is going to affect how the watershed is impacted. So anyway, one thing I like about this, the foundation boxes, is anytime that they can, they really try to put Pennsylvania context into the standards. So your science and engineering practices is analyze and interpret data, your content there with your core ideas, your cross-cutting concepts, cause and effect, and then stability and change. STEM practices, obviously we were planning and carrying out investigations. We developed and used a model to try to see what the runoff is like, and then we also analyzed and interpreted data. Whereas we don't have quantitative data for this particular model or experiment, we do have qualitative. So, and that's perfectly fine as well.